Now, under this one, still we are kind of in the process of a brief review from your prerequisites, followed by the time value of money, what we did last week, right? So basically, in this chapter, we're going to focus on these two rules. We call it net present value and the internal rate of return, right? So before we jump in onto the main story, at least we have to make sure to distinguish two different types of the projects. So whether the projects could be identified as independent or mutually exclusive, our decision criteria becomes different. So then what do we call a projects that are independent? So independent projects are, we call it often referred to standalone projects. So whether you can make a decision separately or independently and does not depend on any of other different types of the projects. Whether we should accept it or not, that could be done separately, independently, and does not depend on any of other types of the projects. That's what we call it, the case of independent projects, right? And among the projects that we have, if we have to just pick only one of them, right? Then that's the case we call those projects are mutually exclusive. All right. So for the net present value, this is our first decision rule. So I think we touched the bottom of net present value from last week, right? We decided to call it net because we are discounting all those present value of all the potential cash outflows and the inflows. Take the difference. That's why we refer to net present value, right? So again, just like we figured out, depending on which types of the projects you are dealing with, if the projects are independent, then what we can do based on the NPV rule is basically accept any of those projects that give you positive NPV. So it becomes way much more straightforward, right? Whereas if you are dealing with any of those projects are mutually exclusive, then what do you do? Under the two conditions. So first one, pick out all the projects that gives you positive NPV, still the same rule as here, right? Whereas from any of those projects that give you positive NPV, pick the highest because now we are talking about projects that are mutually exclusive, right? So here we have a simple example. So two different types of the projects that we have, Project L and Project S, from the beginning of the year 0 up until year 3. So we have different streams of cash flows for those two different projects. So assuming the cost of capital 10%, then we can actually derive net present value for Project L, right? So basically, when net present value, how it works is basically discount all those cash flows that are not located on time 0. If we sum those up, this should give you the total value of net present value for Project L, right? So going back to the timeline, this is what your Excel or calculators is doing for you. So discount all those cash flows that are not located on time 0 all the way back into today, right? Sum those up. Then you have the total net present value, right? So the first three part here, those are cash inflows, and we only have one single cash outflow that happened today, right? So I believe you can do this in Excel too. So we have the innate NPV function. So once you run that function, the first input the Excel is asking you should be the interest rate 10%, right? And then you have to type in all those potential cash inflows as your inputs. Now, one thing to be careful here would be once you type in any of those inputs, within this NPV function, that means this NPV function will discount those cash flows under the 10% for you, right? So in other words, these are the only cash flows that we have to include under the NPV function, right? Whereas we had to add in separately for this negative 100 cash outflow. We're doing this because this negative 100 cash flow is already on time zero. So there's nothing that we have to discount for this. So basically, that's how you get your NPV for project L, right? What about project S? So we have slightly different streams of the cash flows, but still assuming the same 10% of weighted average cost of capital. Once you do your calculation, NPV should be around 19.98. Let's see if this is the case. So NPV, still it's 10% of weighted average cost of capital. Now we have slightly different cash inflows, right? But we add in the initial cash outflow separately. Then we have the same answer, right? That's how we get an NPV. So again, please note that even though you get the NPV calculation correct, once you have to make a decision based on the projects you're dealing with, right? Then depending on whether they are independent or mutually exclusive, your decision criteria should be different. So if the projects could be considered all independent, then problem is simple. Just pick out all those projects that give you positive NPV, right? But if they are mutually exclusive, for example, for this one, these two projects, then we know that these two projects that gives you positive NPV. So it actually passes the first condition, but make sure to pick highest, right? So in this case, NPVS, we should pick this one over NPVL, right? So then problem is this. Okay, so we've learned how to make a decision based on the NPV rule, depending on different types of the projects. Now, the problem is, what if I ask you, you did your calculation, but you figured out NPV is equal to zero or almost equal to zero. So then the question is, if this is the case, are you going to accept the project or no? Right? So it's an open discussion question whether once we figure out a specific project's NPV that gives us almost zero NPV, right? It's not negative, but if that's the case that turns out, then what do we do? So under the original norm of NPV, we should not accept it, right? But in reality, the case might be really something difficult to make decision just depending on the numbers that we see from the NPV. So hopefully you guys recognize what the logo this is, which company actually stands for. So this is called the logo from Unilever, right? And I believe Unilever is also a publicly listed company in the New York Stock Exchange too. So any of those products you see from the screen that actually belongs under Unilever. Now, I'm bringing this up because what Unilever actually did in year 2010 was quite unique. So this was the case of the year where corporate social responsibility was quite prevalent. So companies doesn't necessarily follow and pursue profits only, but they are probably responsible for any of those social impacts too. That's what we mainly refer as a keyword to remember from the corporate social responsibility trend, right? And what the Unilever actually did tried to introduce in year 2010 was what they call it, sustainable living plan. So they wanted to improve the positive social impact and the following policies. What controversial thing happened was once these projects were introduced, they actually did their own calculation on NPV, which turns out to be almost zero in the short term. So did they had to abandon this or did they proceed? Well, eventually they did proceed, right? And it actually turned out really positive. So they were able to kind of come up with a very successful performance based on this new sustainable living plan. And this is how the stock price actually went up since the implementation of the plan by the year of 2010. And you can see the stock price of the Unilever actually went up, right? So then, question is, does this should be always the case? You know, even though a project's NPV actually gives you around zero or even negative, almost negative, but depending on the social impact or other factors that you have to incorporate, you can always expect a positive outcome from this. Well, obviously no, right? So hopefully this one is way much easier logo for you to kind of recognize. Volkswagen, right? And they did also the similar thing in 2015, but in a very different way. So they wanted to engage in what's called the greenwashing. This is a new terminology where if the company wants to improve their societal or environmental impact, but not fundamentally, but instead of doing so, what they what if the companies actually do superficial policies to improve those societal or environmental impact without any fundamental change, that's the case we call it a greenwashing. So what they did was kind of a fraud in some cases. So they tried to install what's called the defeat devices in diesel vehicles and try to advertise and do the promotion. This is way much friendly, environmental friendly for you, but they kind of faked it, the laboratory setting. And it turns out the examination actually figured out this was a fake. So the company had to at least pay a huge amount of settlement in the US alone. And this is what stock price actually did. From the year of 2015, once the market actually figured out, and this is how the stock price actually happened since then. So as you can see, only depending on the NPV, whether that gives you a positive or no, I mean, that should be still considered as a basic norm when it comes to the investment decision criteria, but still, in reality, there are so many things to kind of address and concerned, right? Now, give it a try on this one. I'll give you a couple of minutes. So even though this is an online format, try to pause your video here, take some minutes, and try to figure out what's the correct answer for this. Now, assuming you guys have done this, correct answer should be A in this case, right? So pretty much simple format, just two different timings, right? We have only one cash inflow coming in year one and one single cash outflow at the initial time period 0 under the cost of capital 4%. So hopefully this wasn't too bad for you. Now try this one too. Now, assuming you have done this, this is slightly a bit longer maturity, right? Longer time horizon we have to think of, but still in the same format. We have the initial cost of 81.6. So this is your timeline. We have only one single cash outflow beginning at the year 0, followed by 428 cash inflows in a row, right? Under the interest rate of 10%. So this is your NPV. And according to Excel, I believe this is the same inputs, right? So use your NPV function under the 10% of interest rate, but always remember, try to include those cash flows that should be discounted back, except in this case, 81.6, which is already on time zero, which is our cash outflow, the only cash outflow, right? So is the NPV the only rule that we can come up with when it comes to investment decision rules? Well, we have another one coming up, right? Which we call it internal rate of return. We're going to figure it out very soon. All right, so next rule that we have to at least cover is what we call internal rate of return. So I believe you guys all know theoretically what internal rate of return actually stands for. So IRR, in brief, that's basically the interest rate that satisfies NPV equal to zero, right? Problem is, I know we already have one decision rule, NPV, but why do we even have to care for this so-called IRR? I mean, I saw many of those students actually understand this IRR technically, right? But the main implication of the IRR, I think that's way much more important for us to understand. And the fact that the reason why we are using this internal rate of return over the net present value, I think understanding that should be quite important. So if you understand and go back to your knowledge all the way back into bond valuation, right? Do you guys all remember what we refer to yield to maturity, right? So what does yield to maturity actually gives us as an implication? And further question is this, right? The main reason we are learning this yield to maturity, even though we learned how to evaluate and come up with the price of the bond, is that's the key. And I think if you understand this, then we should have no problem understanding the same context, in the same context, why we're learning internal rate of return. So suppose this is what happens. So if I tell you over the last few weeks, I went out to the bond market and all of a sudden I tell you I bought this bond, this is quite a big deal, and the price of the bond was actually around 988.70. Yeah, I understand, but is that cheap or no? Well, unless I give you further information about interest rate, maturity, right? I mean, there's nothing much that I can actually tell you about how much profit I can expect from this bond just by relying on the price itself, right? Then let's change the question. So if I tell you still the same bond that I got, but if I hold that up until maturity, I should be able to expect at least 7% of interest rate, yield to maturity. Now, that's actually one reason why we are using yield to maturity over the bond price itself. So yield to maturity is, in other words, the same expression of the price of the bond, but in terms of the percentage, right? So then price of the bond could be understood in the same context of NPV, whereas yield to maturity, this is a very similar concept that we see here, IRR. So you can come up with the fair price of the project, which is measured by the net present value, right? But if you really wonder how much profit and percentage that you can expect a project that actually gives you, then IRR is something that you want to go up for, all right? So again, IRR is the same thing as NPV, but in terms of the percentage. So again, technically IRR is the interest rate that satisfies net present value equal to zero, correct? So I believe you can actually do your own calculation in your calculator too, but using the Excel, well, it's way much simpler than net present value because interest rate that we are deriving here right now. So just type in IRR. Well, for the internal rate of return, we have to at least include all those cash flows that we want to address. So nothing about it, whether it's already on time zero or no, right? So just include all those cash flows that you have to at least address. Then you get your IRR for project L. Again, for the project S, just include all those cash flows. Then Excel will do the work, right? So that was the internal rate of return for project L. And you got your project for S, right? So still under the internal rate of return, take any investments where the IRR exceeds the cost of capital. That's the norm, right? That means if the cost that has been required to implement this project actually fall below the IRR, then you go out for it. Because IRR, just like in the similar context of the bond valuation, that gives you the percentage rate that you can expect by implementing this project. If the costs fall behind those, then that's the investment where you have to go out for it, right? Now, let's take this example. So to figure out the relationship between the net present value of the IRR, right? So think about this one. Projects cost 250 million and expected to generate the cash flows of 35 million per year, but that lasts forever. So under the timeline, it should look like this. We are accompanied with one single cash outflow at time zero, and this cash inflow that happens from year one actually lasts forever. last forever. This is the key, right? And I think so far we've learned only one financial instrument that fits into this category when you come up with a keyword of forever. That's the perpetuity, right? And do you all remember what was the present value of the perpetuity? That was PMT, the repetitive payment, over R, wasn't it? And even much more important thing is, once you come up with this present value of the perpetuity, according to our timeline, where should that end up with? Where should that locate? So please note that our present value of the perpetuity should locate one period before our first PMT, which in this case, our first PMT happened in year 1, right? So our present value of the perpetuity should locate at time 0. So can we write NPV for this specific stream of cash flow as this? 250, which is a cash outflow that's already on time 0. 35 is our PMT. So this whole thing, which is the present value of the perpetuity that takes care of all those cash outflow from year 1 to forever, right? These two are already on time 0, right? So that's why we can actually address by using the summation, because they are located on the same timing, right? Problem is this. We figured out an expression of the NPV, right? What was the definition of IRR? Internal rate of return, that was interest rate that satisfies NPV equal to 0, correct? So we can actually derive an expression of internal rate of return. If we solve out this formula, that should give us around 14%, right? This is the amount of percentage rate that we can expect if we implement this project right away, right? So again, if the cost of capital, this is our cost, right? If our cost falls below 14%, that should be the project. We should go out for it and accept it, correct? And that's exactly the case when we can expect a positive NPV. So if we can actually draw a diagram, a figure, that should look like this. So our horizontal axis is the rate of return, right? Whereas the vertical axis, this stands for the NPV itself. So if this is the case, we have this internal rate of return of 14% here. Why is this our internal rate of return? Because just like what we figured out, IRR is the interest rate that satisfies NPV equal to 0, correct? What's the level of this IRR? What's the level of NPV for this IRR? 0, correct? And when it's the case, if our cost of capital falls below internal rate of return, we begin to have a positive NPV, right? The less cost that we have, the higher the NPV that we have. And whenever it comes to the case, the cost falls above, higher than our internal rate of return, our net present value falls below 0, correct? That's how we interpret this NPV profile. So depending on the level of internal rate of return, we can actually make a decision, right? How the NPV would behave and whether to accept or reject the project. So going all the way back into the norm, still similar figure, right? We have cost of capital on the horizontal axis, where vertical axis unit, that's NPV. Then this intersection, right, where IRR, that gives us 0 NPV, this is the location of our IRR. And whenever this cost of capital falls below internal rate of return, that's the case we can expect a positive NPV, right? And vice versa, if the cost of capital falls above, way higher than the internal rate of return, that's the case we can expect a negative NPV. So hopefully this actually makes sense for you guys. Problem is, does IRR and NPV always brings us to the same destination? So in other words, does the decision based on the NPV and IRR always come up with the same answer? Well, unfortunately, the answer is no, right? So depending on which types of situation or projects that you are dealing with, IRR and NPV could tell you a very different thing. And those pitfalls, those scenarios that we are going to focus on for the rest of the chapter. So these are the 4 main cases where we can expect IRR and the NPV would tell us a very different answer. Now, as a first step, first scenario, we call it delayed investments, right? So this cash flow is pretty much way much opposite as those cash flows that we have seen so far, right? So far, we've only had one single cash outflow as an investment. And as a compensation, we were able to expect following subsequent cash inflows, followed by an initial investment, right? However, if the cash flows actually looks way much opposite, and we actually have cash inflow at the beginning of the period, followed by a stream of cash outflow, then IRR and NPV should actually tell us something very opposite. That's the case when the cost of capital falls above, higher than IRR, then we begin to have NPV, high positive NPV. Now, this is not exactly something difficult to understand, because from year 1 up until year 3, the cash flows that should be discounted for, those are now cash outflows, right? Not the cash inflows. So the higher interest rate that we use to discount these cash flows back into time 0, the present value of these cash flows should actually go down. That's why we have higher interest rate than we have higher NPV in this case. Now, I know this is highly unrealistic in some sense compared to any of those projects that generate those cash flows, just like what we see in reality. But real life example of this cash flow may be any infrastructure development with, let's say, any initial grants. So for example, if a government or institution actually received upfront grants or subsidies for large projects at the beginning of the period, and whenever they have to deal with any of those potential cash outflows, where they spend the funds on the project's construction or operation, maintenance over time, this is how the cash flows actually look like, right? So if that's the case, then the consensus, what we learned from the relationship between the IRR and NPV actually overturns. Now, there are also another case where we might not even have any of those internal rate of return. Now, we can only observe internal rate of return if there's a switch of the direction between the signs of the cash flows. Now, for example, in an extreme case, if the cash flow actually looks like this, and both of these cash flows that are on time 0 and 4, if they're all positive, right, then no matter which certain level of interest rate that we use, right, the NPV of this project doesn't really fall below 0. So in other words, that means we don't have any intersection of this horizontal axis. That means we don't have an IRR itself, right? So this is another extreme case where NPV and IRR could tell you a very different story. Now, this could be a bit tricky. When it comes to mutually exclusive projects, then we might also have a conflict. Now, when it comes to projects that are independent, I mean, it's way much straightforward for us to understand. And there's not much possibility where IRR and NPV would tell us something very different. So again, if this is the case of the IRR, and if we're talking about independent projects, any of those cases, cost of capital falls below IRR, that's the case where we should accept it, and vice versa, right? Only for the case when the projects were independent, where we can assume. Now, if we assume the projects are mutually exclusive, now we can have something very different. Now, let's suppose this one. There are two different types of project L and project S. What we do know is this. Project S actually gave you higher internal rate of return, around 23.5%, right? And we know, according to the IRR rule, project S actually dominates project L. Project L actually has around 18.1% of internal rate of return. Now, if the NPV would actually has to tell you the same story, right? Just like what you see here, up until cost of capital actually reached up to 8.7, NPV actually tells you the same story. NPV of the project S is way above than project L, right? So any of those cases, the cost of capital falls higher than 8.7, right? So this is the case where interest rate cost of capital is higher than 8.7, NPV and IRR should actually tell you the same story. Problem is, based on this 8.7%, which is a certain crossover rate, which we call it, if the cost of capital falls below that, right, still we have the IRR rule, project S dominates project L, but look at what happens from NPV. Now project L's NPV is way higher than project S is, right? So there is actually a conflict. And this can actually happen if the projects are mutually exclusive. Now, if this is the case, one of the keywords is to find this one, which we call it crossover rate, right? And we can actually find this crossover rate by doing this. You take the difference between the cash flows, between the two cash flows, right? For project L and S. So now this is your new streams of cash flow. And if you calculate the internal rate of return of this new cash flows, that should give you this 8.68% of the which we call it crossover rate. Now, of course, once you've done this and you can't really find any of those crossover rate, that means one project dominates the other. That means we won't really have any conflicts as you see from here. Now, let's see if this is the case and we can figure out the crossover rate. So what I've done here, still it's the same example what you've seen before, the internal rate of project L and S. So what I've done here was to take the difference of these cash flows between the project L and S, right? So negative 60 came from 10 minus 70. Also the case for the following two streams of cash flows. So this is basically the difference of the cash flows between project L and S. But if I take the internal rate of return of this new streams of cash flows, this is how it looks. 8.68%, we call this a crossover rate, right? That's how you find your own crossover rate for any of those cases that you have to deal with projects that are mutually exclusive. Now, we might even have multiple internal rate of returns. So this is also another problem for the IRRs, right? And to figure this out, we have to learn at least whether the project's cash flows could be defined as normal or non-normal. So you call it normal cash flow if we can see just only one single time of the sign change. So for example, for this cash flow, right, there was only one single change between the signs of the cash flows between time period 0 and 1, right? So this deserves to be qualified as normal cash flow. However, for the second row, right, still the same thing when we observe from between time 0 and 1. But here's another switch that follows, right, between year 4 and 5. So this is exactly the case when we call it non-normal cash flow, right? So following that rule, you can actually figure it out for the rest of the three rows whether those cash flows could be normal or non-normal. And whenever it's the case we see for the non-normal cash flow, right, then that's the case where we can see two multiple internal rate of returns, which actually gives us question which IRR is the correct one, right? So if this is the case, then we can no longer actually rely on the internal rate of return decision rule. So if that's the case, that's one point where we have to at least come up with an answer using what's called the modified internal rate of return. We call it MIRR. So how to come up with MIRR? This is slightly difficult to proceed with the calculators. So I would highly recommend to use Excel to at least come up with an answer for the MIRR. So basically this is a rule. Discount all those cash outflows using the cost of capital. So we are moving all those cash outflows back to time 0, compound all the cash inflows to the terminal year, which is usually the end of our time horizon, and then set those equal by using the MIRR once we calculate the internal rate of return. That's our what's called MIRR. So basically for project L, this is how you do your own calculation for MIRR. So these were the cash inflows, right? We compound all those to the terminal value, which we refer to as the last time of our time horizon. And this was the only cash outflow that we had, right? So if we set those equal and find the interest rate that satisfies this present value formula, that should give us what's called the MIRR. And how you do this in Excel, still the same format, right? So we had the internal rate of return, and under the 10% of interest rate that we are using, basically what you have to do to calculate the MIRR, there's innate function of modified internal rate of return too. So include all the values here, right? And basically it's asking us to type in the finance rate and reinvestment rate. In this case, we just use the same weighted average cost of capital. Then you have your own MIRR here. Still the same case for project S. Include all the values you want to address. Weighted average cost of capital twice. Then should give you modified internal rate of return. Now, this is extremely difficult to do under the calculator, so I would highly recommend to do this on your Excel system. Now, assuming that made sense, try to work on this one. I'll give you a couple of minutes. Now, if you have done so, then let's check it out together. So under the NPV rule, right? You have to make a decision whether to accept this project or no, right? So hopefully this NPV calculation wasn't too difficult for you. It's just discount all those cash flows that are not on time zero, right? And take out the initial amount of investment. Still, you have the positive NPV. So under the NPV rule, you have to accept it, right? But what about the IRR? Even without doing your calculation, at least you need to figure out this specific stream of cash flow is non-normal, which would give you more than one internal rate of return. So our answer based on the IRR rule, we can't really tell, right? All right, so then try this one. This might be a slightly more tricky, I think. Now, assuming you have done, so let's figure this out together. So correct answer should be B. And this is basically the information that we have, right? Under the internal rate of return, project X actually dominates project Y. Whereas at the level of 10% of weighted average cost of capital, we see the decision actually got overturned based on the net present value. Now, even though this is the only two information that we can derive from this paragraph, right? So actually we have no problem picking up on the answer because this means at least the crossover rate should be greater than 10%, wasn't it? Otherwise, NPV rule should not actually tell us something different from what we have observed from IRR. So at least what we can presume is that the crossover rate should be at least higher than the 10%, which we have overturned decision depending on based on the NPV. So if the weighted average cost of capital is 8%, which is lower than here, 10%, then NPVY should be higher than NPVX, right? Which is not the case for C as well. Well, if the cost of capital is around 18%, right? Project Y will have a higher NPV. Now, is this true? Well, I don't think so because the internal rate of return of the project Y is already 7%, 17%, right? So if the cost of capital is way above than project Y, right? If the cost of capital is 18% and that's way above the IRR of project Y, so at least what we can figure out is the NPV for Y for the cost of capital at the level of 18%. That should be the case when we have negative NPV for project Y, right? So that's the only information that we can derive here. And this should be the case, I believe. This is the only scenario that we can come up with. So at the level of 10%, NPV decision actually got overturned compared to the IRR, right? So at least what we can presume would be the crossover rate should be at least higher than 10%. Now, there's one last tool, one last decision rule we can rely on, which we call it payback rule, right? Which gives you the amount of time, basically, how it takes to recover or pay back the initial amount of investment that you paid at the beginning of the period. But there's a huge problem of this payback rule. It actually ignores the concept of the time value of money. So even though the calculation of the payback rule is not as too much difficult as NPV or IRR, right? For example, if these are the three main projects with the initial cost and the cash flow following, then this is basically the answer for the payback rule. However, even though the calculation itself is not too much difficult, because the fact that the payback rule ignores the time value of money, now compared to these two rules, it is not quite advisable to rely on the payback rule. Now, whereas, given the resources, right, constrains the profitability index, we can actually derive an expression that we call it profitability index based on the NPV that we actually calculated. So when it comes to decision-making process between those projects, profitability index can actually give you a quite good measure, right, that can help you to make a decision whether to accept the project or not. So for this, we have to calculate at least beginning from the NPV calculation. So this might be a good example that could actually give you an exercise how to calculate the profitability index. Now, assuming you have done this, correct answer should be A. And this is basically profitability index, right? NPV over the initial amount of investment. Now we know that our initial amount of investment here was 450,000. So once you do your NPV calculation, this is our NPV. All you have to do is divide that using the value of initial investment, which is 450,000. That should give you around 0.39. That's your profitability index for this practice problem 6. Now what you can do from Excel, basically calculate the NPV first, right? Under the 16%. Please always note that when it comes to NPV calculation, time value of money matters. So these are the inflows that should be discounted. And you have to add in separately the initial amount of investment. Now this is your NPV. What I'm going to do here for the profitability index calculation, I'll take the NPV. I have to divide it using the initial amount of cash outflow, right? Because our initial amount of cash outflow is already negative. I'll use absolute value, right? Which will give me without the negative sign on. And that's basically your profitability index.